You ever stop and think about what actually happens when you type a website into your browser and hit enter? I mean, in that split second, it feels like magic, but it's not. It's one of the most critical systems on the internet, the Domain Name System, or DNS. So let's pull back the curtain and see how the internet's giant directory really works. Here's the plan. We're going to start with what I call the internet's magic trick. Then, we'll follow a request on a kind of detective's journey. After that, we'll peek inside the files to look for clues, figure out how the system gets so blazing fast, and finally, talk about how we try to keep this whole directory secure. All right, let's kick things off with that magic trick. You know, the one we all do probably hundreds of times a day without even thinking about it. Seriously, think about it. You type a simple name, and somehow, out of billions of places to go, your computer just knows. Well, the thing is, your browser has no clue what example.com actually means. It needs a number, a specific address, to find anything on the huge map of the internet. And that, right there, is the entire reason DNS was invented. We're good with names, right? Example.com is easy. But computers? They talk in numbers, these long strings called IP addresses. DNS is basically the ultimate translator, bridging that gap between how we talk and how machines talk. Believe it or not, way back in the early days, this was all handled by one single file called hosts.txt. Yeah, imagine one giant contact list for every single computer on the network that someone had to update by hand. As you can guess, when the internet started to explode, that became totally impossible. So, in the 80s, DNS was born, a system designed to be spread out, automated, and able to grow as big as the internet needed it to. So to really understand how this whole thing works, let's follow a single request from start to finish. We're going to treat it like a detective story. The mission? To hunt down the secret IP address of a website. Our little investigation has 4 main stops. It all starts with something called a recursive resolver. From there, we go to a root server, then a TLD server, and finally, we hit the jackpot at the authoritative name server. Let's go meet the key players in our story. First up, the recursive resolver. Your internet service provider probably runs this for you. This is our lead detective, our private eye. When your computer needs an address, it just hands the case off to the resolver, and its entire job is to go out into the internet and find the answer. It does all the hard work for you. So the first place our detective goes is to a root server. The best way to think about this is like a master librarian in a giant global library. The root server doesn't know where every single book is, but it knows which section to send you to. It sees you're looking for example.com and it says, aha, that's a .com. You need to talk to the .com specialist. Which, of course, brings us to our next character, the top-level domain server, or TLD server. This is our specialist librarian. They only handle one section. In this case, every single domain that ends in .com. Now, this server still doesn't have the final answer, but it's got the last crucial clue. It knows the exact server that holds the official records for example.com. And at last, our detective arrives at the authoritative name server. This is it, the end of the line. This is the official bookkeeper for the example.com domain. It holds the definitive file, the real source of truth, and it provides the final answer our detective was looking for, the IP address. And just like that, case closed. The authoritative name server gives the IP address to the recursive resolver, which gives it back to your computer. Your browser now has the number it needed all along, it connects to the server, and poof, the website loads on your screen. But here is a cool little twist. That answer our detective gets, it's usually not just a single IP address. It's actually a whole file full of different types of records, kind of like clues that tell the internet all the different ways it can interact with that domain. Here are some of the most common ones you'll see. That A record, that's the one we've been chasing this whole time. It maps the name to a regular IP address. But there are other really important ones, like the MX record. That's what tells the world where to send your email. Or a CNAME record, which is basically a nickname, pointing one domain to another. So that whole detective journey happens in the blink of an eye. But the internet is obsessed with speed, so it's got a really clever way to make things even faster, so you don't have to do that whole journey every single time. The secret sauce is something called caching. Get this, 0.0005 seconds. That's how ridiculously fast a lookup can be when the answer is cached. Instead of that whole trip, you get the answer almost instantly. So how on earth is that possible? Well, the answer is pretty simple. The system is designed to remember things.
Once that whole detective journey is done once, the answer gets stored temporarily, or cached, in a bunch of different places. Your web browser has its own cache, your operating system has one, and our friendly neighborhood recursive resolver, it keeps a big cache too. So the next time you ask, the answer is probably already waiting nearby.
But you can't just remember the answer forever, right? I mean, what if the IP address changes? That's where something called the time to live, or TTL, comes in. It's basically an expiration date that the domain owner sets on the record. It tells all those caches exactly how long they should trust the information before they have to go out and ask for a fresh copy. Okay, this brings us to a really critical part of the modern internet. DNS was originally designed for a small, open, and trusted network. Security really wasn't the top priority. But today, in our world, protecting this directory is absolutely essential. And this lays out the battle perfectly. On one hand, you have attackers trying to forge DNS responses, it's called spoofing, to send you to a fake website instead of your real bank. The defense against that is DNSSEC, which is like adding a digital signature to the data to prove it's legit. On the other hand, old-school DNS queries were just sent out in plain text for anyone to see. So now we have things like DNS over HTTPS, which encrypts those requests to protect your privacy. So when you put it all together, you realize DNS is so much more than a phone book. It's this invisible, incredibly smart, layered system that's constantly working in the background. It is, without a doubt, the essential foundation that makes the internet something we can all actually use every day. Which kind of leaves us with this one big final thought. This amazing directory was built on the idea of being open and trusting. As we keep adding these new layers of security and privacy on top of it, the real question is how it's all going to evolve. Can a system that was fundamentally designed to be open transform into one that's also perfectly private and secure for whatever the future holds?